Welcome to Spring Lib.
We are told that many gases are shipped in high pressure containers. So we're given our first tank has a volume of 55.0 gallons. It contains O2 gas at 16,500 kilopascals at 23 degrees Celsius. And we have 4 questions to answer. A is mass of O2 in tank. Okay, let's get started. Mass of O2. Let me pick a pretty color for this one. So first of all, let's figure out our gallons. I've got 55 gallons times 3.795 liters per gallon. And that will equal 55 times 3.795 is 208.7 or 209 liters. I'm using different earbuds and I feel like they're going dead, but I'm going to finish this problem. My pressure, we were told, was 6,500 kilopascals. I don't need to go to kilopascals. I don't need to do this. I can stay in kilopascals. So we're going to find moles, which will be PV over RT. So P was 1,6,500 kPas times 208.7 liters times R, 8.314 lkPa per kmol times my temperature, 273. You can use the 1 pi at 5 or not. I'm going to use 296.15 Kelvin. My N will equal 16,500 times 208.7 divide 8.314 divide 296.15, enter. And I get 1398.6 moles. Finally, I'm going to take 1398.6 moles times 32 grams per mole. And this will equal times 32. Ooh, I better go check my sig figs here. There's 3. So I can go to 3 sig figs. 4.48 times 10 to the 1, 2, 3, 4 grams. There's my mass. Now the second thing I'm asked, what volume would this occupy? What volume would this occupy at STP? Okay. Okay, so I know what my moles are. We had 1398.6 moles times 22.4 liters per mole. 1398.6 times 22.4 is 3.13 times 10 to the 1, 2, 3, 4 liters. Okay. Now, let's do our next one. So far, this hasn't been bad. Let's do C. At what temperature would P equal 150.0 atmospheres? Okay, this one isn't going to be too bad. Do I need to worry about my volume? I do not. At what temperature volume is staying the same? Okay, let's do this. My my temperature will equal P2 was 150.0 atmospheres. Was it atmospheres? Shoot. And P1 is 16500 kPAs, and that'll be 101.3 kPAs per atmosphere. And my temperature was 296.15. Let's see what we get here. 150 times 296.15 divided by parentheses 16500 divided by 101.3. Close, enter. And I get 272.7 K. This will equal I can go to 3 sig figs on this one. That'll be 273 K equals 0 degrees Celsius. So either one of those numbers. There, that was C. One more, D. What be the pressure in kPAs if it were transferred to a 55.0 liter container at 24 degrees Celsius? Can I do combined gas law on that? I can. So let's do P1, P2 is question mark. P1 is 16,500 kPAs. V1 and V2. V1 is, let's get way up here, 208.7. And this is 55.0 liters. And T1 and T2. This is 296.15, and this is 297.15. So we'll be using P1 V1 over T1 equals P2 V2 over T2. We're solving for P2. P2 will equal P1 V1 T2 over V2 T1. Let's plug our values in. P1 V1 T2 divided by V2 divided by T1. Okay, let's see what I've got here. 16500, whoopsie, 500, clear. 16500 times 208.7 times 297.15 divided by 55 divided by 296.15. And I get 62,821 kPAs. It'll be a lot there. So I get P2 is equal to 6.28 times 10 to the 4th kilopascals. That was a long problem, but it was sort of fun.